is a very, actually it's quite easy if you understand the concept, but I'm going to go through it slowly with you, because last time this topic used to be in A-Maths. Okay, but they involve 3 sets, 4 sets, and then people get confused. But now they have, long time ago, once upon a time, I don't know when, they decided to put it into E-Maths. So when they put it into E-Maths, now we have left 2 sets, that's all. 2 sets. So 2 sets is easier than 3, 4 sets. Do you understand what I'm talking about? Okay, what is the meaning of a set? Okay, I'm going to teach you this. Don't be so frightened by all the notation and so on, and then freak out, that kind of thing, okay? Now, for example, in English, right, you must have those things like a deck of cards, alright, a group of students, a flock of sheep, a flock of sheep, yes, I think so. A flock of sheep, what do you think I did? I did not okay one name. Okay, that's the fruit of chicken, am I right? A flight of stairs, right? Don't think I don't know, okay? A fleet of what? A fleet of sheep. Sheep, oh, I thought a fleet of fish, right? School of fish. Is it a school of fish? Oh my god, okay, whatever. Now, in maths, luckily I'm a maths teacher, everything is called a set. A set of students, a set of fish, a set of cows, a set of tables, a set of dogs. That's not finished. Set. Understand? No need to be so particular. Clear or not clear? Okay, but when we talk about it, the set must be also well defined. Okay, well defined. That is, you must know what belongs to the set. For example, I say the set of. You know what's the advantage is the everything of this one. Last year also. Okay, but a set must be well defined. For example, I say a set of 4 3 students will only be held. And a number of elements or members. Usually we use elements. Number of elements or members in a set will involve the 40 of you. Understand? Okay? So I can list down the set and so on. There are different ways to list down the set. Everybody clear? It must be well defined. Alright? Now, I'll give you another example. The set of handsome boys. This is not well defined. You know why? Someone looks very ugly but is handsome to you. But someone looks very handsome to me but is very ugly to you. It's subjective. You understand? Or a beautiful girl. That's rubbish. You understand? You don't go away like that. But if I say the max teacher teaching 403, confirm is me, that's it, well defined. Everybody clear with what I'm saying? Okay, you don't go and like, wow, blur like that, I cannot. Okay, come. Let's take a look at page 3. Introduction to set notations. There's a lot of notations here, but I don't need to be worried about it, okay? As the time goes by, we'll be okay with it. Just like in primary school. You see the equal sign very brighter, right? Then secondary school, we have not equal, right? Okay, then we have this one, then after that we have this one, we have all very brighter, right? Actually, it's okay, right? Then we have approximately, it's just these symbols to tell you that it's words, that's all. But maths is full of symbols, that's all. Okay? Alright, now next, first thing. In everyday life, we often encounter a collection of objects such as a pile of books, a bunch of keys, a piece of rubber, okay? In English, we use different terms such as all these, alright? In mathematics, we use the term set to describe any collection of well-defined and distinct objects. Distinct means what? Cannot repeat. Understand what I'm talking about? When you list a set, you do not repeat the element. You get what I'm saying? Okay, I will tell you more later. Don't not to worry so much. So it must be well-defined and what? Distinct. Okay? Now next, for example, if we let S be the set of all the vowels in the English alphabet, we can list all the members or the elements of S in the set notation now. Vowels will be like that. Now usually, sets, we use a capital letter to represent. Okay, it can be A, it can be B. Like that. A set is always represented by a capital letter. Okay. Now, then we use curly brackets. Curly brackets. You don't use any stupid bracket. Okay. Vowels will be what? A, E, I, O, U. This will be the set of vowels. vowels. Okay. Now, what are those that are non-vowels? What is it called? Consonants. Okay, consonants. Okay. Now, what if I have A, which is the set of all the alphabets? That means how many do I have? Oh, 24. This better go back to kindergarten.
26.
20 what? 6. So, I will have A, B, C, D, E, until what? So, there are 26 elements. They are all well defined. There's no repeat. Okay, so set is represented by a capital letter equals, then curly bracket. You list the elements. You put a comma to distinguish. Understand? Now, another thing is this. Look at the next part. Since the letter A is an element of S, we write this. And letter B is not an element, we write this. And number of elements is 5, we write this. Okay, I'm going to say this on spot here. All of you, I'm going to use these two as examples. Okay? Now, do you agree that A belongs to B? That means A is in the set B. Alright, so A is an element of V. This one means it's an element of, or is a member of the set. That means I can say E is an element of V as well, right? And what else? I is an element of V, O is an element of V, and U is an element of V, right? Alright, this one means it's an element of. How to write? Some people confuse. You write like this, then you put a line here. Understand? Something like a C and then with a line there. You don't write an E, it's not an E, understand? Okay, now, then I want to ask, is W inside here? No. So W is not an element of V. This is what it means. Everybody clear? Everybody clear? Okay, now, then another notation. When I write like that, what does it mean? It is the number of elements in V. How many? This will be 5. Everybody clear? Everybody clear? So, what is the number of elements in A? Javius, I want your answer. 26, right? There are 26 elements. Is that clear to everyone? So, I introduced 3 notations. An element of, not an element of, and number of elements. Are you all okay? And sets are represented by capital letters. Is that clear to everyone here? Everybody okay so far? Because you're going to look at the basics, right? Okay, now, next page. Okay, next page. Alright. And we look at after the class discussion, okay? After the class discussion. This one, if you're not sure or whatever, you just listen to me. When you go to higher level, they will tell you what it is. Understand? But I need you to know the distinction between these two. Okay? Now, in general, a set is not any collection of objects. The objects in the set must be well defined and distinct. I just said that. Correct? I just said that. Okay? Now, if you look at the class discussion on top, all of you look at the class discussion on top. Number 1. Let H be the collection of all the handsome boys in the class. Is H a set? Now, this is not a group. This is not a set because we cannot define properly. Do you understand? Okay, like for example, this is a set of all the good teachers. What do you mean by good teachers? You cannot define that. Do you understand what I'm saying here? Okay, now next one. Number 2. Let T be a collection of 2 identical pairs. How will we list the elements of T? P, 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 or P1, P2. Now, if you have 2 pens, let me just show you. They are identical, right? Okay, but it's still different. No? I picked this one, that means it's not this one. So this is actually, you cannot say PP, because PP means all the same. You cannot list it as 1 because there's 2. So you must find what? P1 and P2. Do you understand? This is what we are trying to tell you. Don't get confused. I'm just telling you what is happening here. Everybody okay? What if there are 3? The P1, P2, P3. Understand? It must be well defined. Okay, you cannot say anything also can. That doesn't matter. Okay, now let me look at point number 3. Okay, point number 3. Let S be the set of letters in the word clever. Now, if I have a word say the set is the words, the letters in the words clever. So I will list. I'll have C, then what? L, then E, then V. I list E again. No, because E is the alphabet. You don't have E1, E2 in the alphabet. So you only list it once. And what about here? So it only consists of C, L, E, V, R. Understand? It's unlike the pen that I'm talking about. Do you understand? Because pen can have pen 1, pen 2. It's different. But the alphabet only got 26. No matter how you write the alphabet, it's still E. Do you get what I'm talking about here? Okay, so this is the difference. Just bear this in mind. This is not really that crucial, but bear this in mind. Will that be clear? When you list the elements, you only list it once. Get it? Okay? Alright, now, so let's take a look at the bottom down there. In the above discussion, we cannot write T is PP because the elements PP are not distinct. Okay, so we must write P1, P2. Can you see? I just told you that. Now, next part. However, in question 3 of the class discussion, the letter E is not distinct in the word clever because it's the same letter E that you use to form the word. Therefore, the set is only C, L, E, V, R. Can you see what I'm talking about here? Yes or no here? Yes, huh? Okay, good. Now, how do we describe a set? Now, this is the most important because our students can list down the elements, but they don't know how to describe a set. Okay? So let's take a look here. This one I'm going to tell you very clearly. There are 3 ways to describe a set. And they can ask you in any 3 ways. First one, describing a set in words. Okay, so first one, describe in what? Words. They give you an example. Let's look at an example then. S is the set of all positive even integers less than 10. Okay. All positive integers less than 10. It must be positive, it must be even, and it must be less than 10. Okay, can 0 count? Why cannot? 0 is neutral, remember? 0 is neither positive or negative. So what should this be? 2, 4, 6, and 8. Because they say less than 10. So this is the set here. Okay? Now, of course, second one is the best. It's called listing. Listing is just like that. You list down and list. Understand? They can describe it in words. They can list. Understand? Okay. Now, the last one is in set notation. Aha. This is the one that students get confused. S, they will use this. Called set notation, and we are interested in the third one. Okay? Now they will say X. This do not mean such that. X is such that X is a positive even integer less than 10, which means it's also zero. Understand what I'm talking about? But if I am the teacher, right, I will not set like that. Now that's so simple. I will say X such that also the same thing. Do you agree it's the same thing? Do you agree that these two is actually the same thing, but I describe it in terms of mathematical terms? X must be between 0 and 10, and X must be an even integer. So it's also 2, 4, 6, 8. Can you see what I'm talking about here? Okay, so a set can be described in 3 ways. Either you describe in words, or you describe by listing the numbers down, or the elements down, or you describe by set notation. This third one is called set notation. Everybody clear with what I'm saying there? Yes or no? Okay, and I've introduced to you 3 symbols. Is an element of, what's this here? Is not an element of, and if I have this as 6, it means the number of elements in set A, there are 6 of them. Everybody clear with what I'm saying here? Can? Okay, and set must be in capital letters, equals to, then you open with curly brackets. It cannot be any other brackets. Follow class. Okay? Alright, good. So this is called describing a set. Alright? Now, I'm going on to work example 1, so on and so forth, until I reach exercise 1A. Okay? And in this particular section, in this particular chapter, before I carry on, there's something that is called a Venn diagram. Venn diagram is very important in set. And we must know how to shape and where's the required region. And I'm going to give you, I think it's 32 examples of how to shape. Okay, and we're going to copy into our notebook later. Now we haven't reached there yet, so I want to copy it. Okay? Okay? Alright, now next one. Let's take a look at book example 1. I'm going to write this on the board and we're going to do it slowly. Okay. It is given that A x such that x is a positive integer. X is a positive such that x, okay, and B is x such that x is a positive also integer between 3 and 11 inclusive. Okay. Now sometimes you like to write a lot of rubbish, but they mean the same thing. Now, for me, right, I always don't like this kind of set notation. It's very difficult for me to imagine. I always like to list it out. Understand now? When you list it out, then you know exactly what is in the set. Okay, now let's take a look at part A. What did they say? Now part 1. List all the elements in A and B in set notation. They want you to list all the elements in A and B. Alright? So let's take a look. All of you look up. Don't look at the text. X is a positive integer such that it's like that. Now you must look carefully at the sign, just like when you do inequalities. Is 2 included? Yes, so I start from 2. And it's an integer. What does an integer mean? Whole number, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it correct? No, you must look carefully. It excludes 11. So this is only until 10. Everybody okay? Now let's take a look at set B. It's a positive integer between 3 and 11 inclusive. What do you mean inclusive? Include the 2 endpoints. So it must be 3, 4, 5, 6, 7, 8, 9, 10, and 11. Everybody clear? Everybody clear? Okay, now next question here. Do A and B contain the same elements? Do A and B contain the same elements? Exactly the same elements? No. If they ask that, that means they are asking you exactly. The answer is no. Okay, because this one got 2, this one don't have. This one got 11, this one don't have. Understand? So they contain different elements. Understand what I'm talking about? Okay, so let's look at the answer. No, because 2 belongs to A, but 2 don't belong to B. You can also say 11 belongs to B, but 11 don't belong to A. Okay, that's why they do not contain the same elements. Everybody clear? Okay, alright, good. So, are we okay with work example 1? Next, I'm going on to equal sets. Now, 2 sets are equal if they are exactly the same. That means the number of elements must be the same. The elements itself must also be the same. Okay, for example, I have A is this. A, B, C, D, E. I have B as this. B, D, E, C, A. Are they equal? The order is not important. Yes, right. They are equal. They are equal when the number of A is equal to the number of B. Okay, and every element of A is also an element of B. They must be equal. Okay? Understand now? Equal number exactly the same. That is called equal. Okay? Now, I can have this. Are these 2 sets have the same number, 1, 2, 3, 4, 5, 5 elements. 1, 2, 3, 4, 5, 5 elements. But they're not the same. Okay? So, if the sets have equal number of elements, doesn't mean that they are same. It can be orange, apple, durian, whatever, then it's not the same also. You can have 5 fruits down there and it's still not the same. For it to be equal, it must be exactly the same. Just like for congruency like that. Everybody clear? Okay, now let's take a look at equal sets. Two sets A and B are equal if they contain exactly the same elements. And we write A is equal to B. For example, A is 1, 2, 3, 4 and B is 2, 4, 1, 3. Then all the elements of A and B are the same. That is A equals to B. Although the order of elements are different in A and B, it doesn't matter. Okay? Now last part. We also notice that if A is equal to B, then number in A is equal to number in B. This is common sense, right? Okay? Now let me just tell you, next time when you go to JC or whatever, you will have this a lot. Even if you go to college, it's also like that. If I tell you that set A is equal to set B, that means what do I mean by that? The two sets are the same, exactly the same, right? That means it will imply that, correct? It will follow that number of elements in A will be number of elements in B, right? But I want to ask, if I have this, right? Does it imply this one imply this confirm? This one, does it imply? I just showed you here. Does it imply? No. This is not true. Everybody clear? You must know which direction it goes. Understand what I'm talking about? Okay, Alright, good. Next, we go on to empty set, or we call it a noun set. Okay, empty set. Or noun set. Now, the notation for empty set, there are two notations here you can use. You put a curly bracket, with nothing here, you put a curly bracket. This is a noun set, because we don't need elements inside. Understand? Then another notation for noun set is like this. Nothing here. Okay? These two are elements for noun set. Okay? What do you mean by noun set? You are talking about in general, okay? In general, dogs have 4 legs, right? Alright, now, you don't kind of exactly ask me what is this exception, no, the dog is really cat, this kind of thing. Don't kind of tell me this kind of rubbish now, okay? Then, I will say, dogs with 6 legs. So this will be a noun set. Because don't have in general, unless it's like abnormal lah. But you don't kind of tell me abnormal, that kind of thing, okay? Don't kind of talk this kind of rubbish during the exam, okay? Do you understand what I'm talking about? Okay? Noun set means nobody is in the particular set. Nothing is in the particular set. Okay? Understand what I'm saying here? Yes or no? Okay, for example, I want to have a noun set. A student who is in 402 and 403. Cannot be what? It's either in 402 or 403 lor. It cannot be 402 and 403 lor. You get what I mean? Yes or no? But if I say a student in 402 or 403, then can. Because it's either or. You get what I'm talking about here? Okay, a student cannot be in 402 as long as it's 403. That's confirmed noun set. Nobody. Go and name one student. Go on now. Don't have right. Okay, unless you see in the middle, I don't know how much. Oh, then I don't know what you where it belongs to. I have 402.5. Okay? Alright, now, so that's a noun set. Let's take a look now. Consider the sets A, 0, 1, 2, B, 0, and C, nothing inside. Set A contains 3 elements, correct? Set B contains 1 element, and that is 0. Alright, and set C does not contain any element. Okay? In other words, C is called an empty or a null set, and we use the symbol pi. Can you see? You don't call this pi, later you're very confused. Just ta. This is called null set, and we describe this as null. Now, if C is a null set, we can write C as a null set. C equals to null set. Understand? Okay? Null set means nothing inside. Okay? Alright, now let's take a look at example 2 now. What's example 2? Okay. Now, it is given that A is the set of vowels in the word rhythm. And B is equals to the element H only. Alright. Okay. Vowels in the word rhythm. Is there any vowels? So it's actually an empty set, right? Alright. A is an empty set. What about B? B got which element inside? H. Understand? This is the meaning here. Okay. Now, list all the elements of A in set notation. Of course, I listed already. Nothing. Here. Okay. Now, B. Part 2. Are A and B equal sets? Of course, no lah. This one got nothing. This one got one element in. Understand what I'm talking about? Oh? So, A and B are not equal sets, as A is an empty set. There is no elements, while B consists of one element H. I told you already, to be equal, they must be exactly the same. Same number of elements and same type of elements. Everybody clear? Can or cannot? Can, huh? Okay, so I've explained all this. Alright? Now, I need you to do some questions for me when by tomorrow. Yes? No need to do on Zoom. This is good in the textbook. And I'll explain tomorrow to you. Okay, this is the basic. Right? I want you to do in your textbook. Exercise 1A. Okay. Every question except number 10. It's very easy one. You just list these, then after that tell people the kind of thing. Tomorrow I will go through. Do everything except number 10. I don't need you to describe. Is that okay? Is that okay? Can you get it done by tomorrow? Can? Okay, just get it done by tomorrow. If you want to do it in your notebook, it's also okay, but I feel there's no need. You just write the answer in your textbook. Then you just carry on with that. Okay? Can? Now, I will do question 1 together with you first, so that you know what I'm talking about. Can? Then after that, I'm going on to section 2. Alright? Okay, now let's take a look at this. Let's look at question 1. I'm going to do question 1 together with you. B is the set of odd positive numbers less than 11. Okay. I want to list first. Positive odd less than 11. What should it be? 1, 2, 3. Wait. 1, 3, what? 5, 7, 9. That's alright. Okay, good. List all the elements of B in set notation. So this is the set notation that we have. We have listed all the elements. Okay, down there. Alright? Okay, write it down. Okay. Then you just have to state true or false. Part 1. 1 is an element of B. I'll write down everything first. 4 is not an element of B. 0 is an element of B. 11 is not an element of B. Okay. It's just true, false, yeah? Now, let's take a look. Is 1 an element of B? Yes, so true. Is 4 not an element of B? 4 is not an element of B, right? So this is also true. Correct? How about this? 0 is an element of B. False. 11 is not an element of B. So it's true, false, true. Everybody okay? Everybody okay? So that's how you go about doing all these things. Everybody okay with this? So tomorrow I will go through these questions, except question 10. Will that be clear to you? Will that be clear to you? Okay, good. Now I'm going on to the next part. Okay. which I'm going to give you the basics again. You just copy question 1, the rest you do it at home. Most likely this is the only set of homework, that's all, nothing. Because I don't want the rest to be done because I need to explain. Okay, now, of course, life is not so simple. Have you taken this down already? I told you to take down, you just write down here in your textbook, right? That's why I said don't need to complicate. Alright. Next part is I'm going to talk about Venn diagrams, universal set and complement of a set. Okay. Now, when we talk about a set, we must have boundaries in our discussion. Okay. Now, for example, I say student. Student is too general. It can be primary school, kindergarten, secondary school, JC, university, alright? So I have to restrict my discussion to something. Okay? What if I say the discussion is Xinmin secondary school students? Then this is called my universal set. A universal set will restrict my discussion. Now, if I say my universal set is secondary school students in Singapore, then the set is bigger. But my discussion is still about this. Okay, now, how do we represent universal set in a Venn diagram? You draw a rectangle. This is the symbol for universal set. Okay, this is the symbol for universal set. That means we are talking about all these within these boundaries. Everybody clear? Everybody clear? Okay, now, for example, my universal set is this. When I say my universal set is this, what does it mean? It means my discussion is bounded from 1 to 10, that's all. I don't care about 100, I don't care about 10,000. That is my discussion. Okay? Now, let's say I have a set A, which is 2, 4, 6, 8, 10. Okay? How do I represent this? Set A is always circle on this circle, understand? A. Now, what element is this? 2, 4, 6, 8, 10. All these are inside my set A, right? Therefore, I draw it inside. What are the elements that are not in set A but is still in the discussion? 1, 3, 5, 7, and 9. Correct? Okay, now can you see that my discussion has got 1 to 10, but this one belongs to set A, this one don't belong to set A. Now what do we call those that is in the discussion but is not in the set A? We call it A complement. The complement of A. Complement means not in set A. Alright, so I will have 1, 3, 5, 7, and 9. Okay? So, universal set, a set, and complement of a set. Complement means not in that set, but is in the discussion. Everybody clear? It's not so easy, okay? It's not so easy. Because when I go to intersection in union, you're going to die. Okay, not die lah. At this point, you will see some stuff. Okay? Everybody okay? Okay? Alright. Now, so I have introduced universal set and also, is my time up? Not yet up. Okay? And also complement of a set. Okay, now next one I'm going to tell you is a subset. Wait up. What are the issues here? I'm going to write down. Can you write down this on page 12 before exercise 1B? This is not given in the text. The noun set and the set itself can you write this sentence down on page 12? Then I'm going to explain something to you before I carry on. the noun set and the set itself are subsets of the set. What do you mean by that? What's a subset first? Okay? Alright. Now I'm going to write something on the board. This one, can you please don't copy? Listen to me first. It's important, okay? All this sets here. Okay, I'm going to explain to you. This is the symbol for subset. Must align below. This is a symbol for proper subset. There's no line below. Can you please take this down? I'm going to explain this up. Have you taken this sentence down already? Have you taken this sentence down? Okay, huh? Alright. Now, can you see that I have the universal set? The universal set consists of what? My discussion is from A to Z. Alright. Now, I want to look at set A. A, B, C, D, E. Okay? Can you see that B is actually inside A? The elements here are actually here, you can see. That means that I will have this. A here, right? All of you look up. Don't copy. Just listen. Please. Because ultimately you will know. B is here, right? C and D is here, right? What is in A but not in C? What's in A but not in B? A, B, and E. Correct. All of you look up here. Can you see that this is the set A? A, B, C, D, E. But my B is only C and D. Okay? B is a subset of A. Okay? It is a subset of A. But B is a proper subset of A because there are extra elements outside. There must be at least one extra outside to be a proper subset. Do you understand what I'm talking about? There must be at least one extra outside. Okay, don't take that first. I'm going to explain. Now, you look at C and A. All of you look at C and A. What do you realize about C and A? A, B, C, D. They are the same, right? They are the same, right? C is also a subset of A, but it is not proper because there's no extra element outside. It's exactly the same. That's why in higher level when you prove, right, how to prove two sets are equal, right? You got to prove A is a subset of B. Okay, for example, down here is C. A is a subset of C, and C is a subset of A, then A will be equal to C. Okay, now, never mind. This one is higher level, you don't worry. This is how we prove in higher level, how we prove that two sets are the same. But in order to be a proper subset, there must be at least one element extra outside that doesn't belong to this. Then this is a proper subset. If not, it's just a subset. Everybody clear? Because nowadays O level want to explain is this a proper subset or not. You get what I'm saying? Okay, now then we look at D. Set D. I want to know set D and set A. How would I draw it? A is here. Do you agree that D, the elements are also here? Okay, so I will draw D inside. Now what do I have here? A, B, C, D. What's the one that is not in D but in A? E, right? Then I want to ask a question. Is D a proper subset of E? I mean, nonsense. Is D a proper subset of A? Yes, because there's one more extra. outside. Do you understand what I'm talking about? Okay, but if let's say I draw C here and it's like that. You see A, B, C, D, E is in C also in A. Can you see there's no extra element outside? Then C is not a proper subset. Proper means there must be extra outside. Okay. Understand? This is my way to explain to you because in exam some people really go and write this up say there's an extra outside. You cannot write like that. This is not mathematically sound. This is what I'm going to explain to you. Do you understand? Now, for it to be a proper subset, let me just draw a diagram for you. Okay? If B is a proper subset, you must have elements here. Then you must at least have one extra. Or you can have two, you can have many. But you must at least have how many? One outside. Okay, now, so how to explain whether B is a subset of A or not? Let me just tell you this first. Don't worry, later when I go, I will tell you how to write it. Now, if it's a proper subset, right? Proper. Every element of B must be an element of A, right? Alright. Every element of B must be an element of A, right? And of course, number in B must be less than number in A, right? Number of elements in B must be less than number of elements. It cannot be equal. If it's equal, then it can be a subset only. It may be a subset. Do you understand what I'm talking about here? So it's very important. Everybody clear with what I'm saying? Can or cannot? So some people always forget, sure, I don't understand what you mean by subset. And set. Whatever nonsense you have. Okay, repeat. Subset can be equal. Understand? Can be less. But if you say something is a proper subset, it must be less. Understand or not? Like proper fraction, top must be less than bottom, right? Okay, so that's how I remember. Proper fraction, top must be less than bottom. So proper subset must be less than the original. Everybody clear? Okay? Alright, good. So, let's take a look. Venn diagrams. Can we all look at page 8 now? Page 8, all of you. We can represent a set using a Venn diagram as shown in figure 1.1. Okay, can you see the rectangle is a universal set? Universal set will bound our discussion. Okay? Now, in figure 1.1, the rectangle represents the set of all the elements that are under consideration for this particular situation. So it's 1, 2, 3, 4, 5. This is called a universal set and is denoted by the symbol down there. Okay? The circle represents the set A, 1, 2, 3. Now we observe that the elements 4 and 5 are outside the circle, but inside the rectangle. That is, 4 is not an element of A, 5 is also not an element of A. The set of all the elements in the universal, but not in A, is called the complement of set A, and is denoted by A prime, pronounced as A prime, and you have this. Alright, all of you look up here. If, let's say, I use back this example, I delete this one. Okay, I delete this one. Okay, let's say I also don't want to have so many. I want to have like that. A, B, C, D, E, F. Like that. Okay. So universal set is A, B, C, D, E, F, G, right? That means my discussion is only from A to G. Now, A is here. What do we have inside? A, B, C, D, E, right? Then F, G is outside, right? Alright, now how do we write A complement? A complement, A prime, is consisting of the elements F and G. A complement means the elements that are not in A. Everybody clear? Okay, you put a prime down there. Okay, this is called a prime in has a not what they call it, apostrophe S. You're not talking about? Okay? Alright, now next. Next page. Example 3, I will go through it tomorrow, and the proper subsets I will again explain it tomorrow, and I will explain the line that I've written down there for you just now. Everybody clear? Okay, now you take the time, like 5 more minutes, you take the time to do the exercise 1A. Don't need to cry if you don't know how to do it, okay? Tomorrow I will go through. Everybody clear?